Hi there, and welcome to another episode of What the Heck is Steve Talking About? Today we're going to go over some resistive series circuits and figure out how all the components of the circuit work with each other and interact with each other. And we're going to get to wire something up on the trainer and do a little bit of math on the whiteboard. So let's get started. And I'd like to start by going over how the different components work in a series circuit. So the voltage, which we are given here at 120 volts, will drop proportionally across each resistor in this series, depending on the amount of resistance in that resistor. But what we do know is whatever the drops are on the resistors, they will always add back up to the total applied voltage. Now the current is a little different. Whatever we calculate the current to be, which we're going to do that in just a moment, that current is always the same no matter where we measure it in a series circuit. It'll be the same across this resistor as it is at that resistor as it is at that resistor. The current only has one path to follow. So whatever we read here, we'll read there, we'll read there. Fair enough. Resistance is additive in a series circuit. So really the total resistance is the sum of each resistor in that series circuit. And that just takes some simple math to figure that out. Okay, so I wanted to take just a second and put this graphic up for you that's going to really apply to everything we do in this video. It's the 3 basic rules for a series circuit. So let's talk about the elements that we're given in this circuit to start out with. We see here we're given that the voltage is 120 volts. That's going to be our input voltage. We are also given the resistance on resistors 1, 2, and 3. We've got 300 ohms on resistor 1, 600 ohms on resistor 2, and 300 ohms on resistor 3. We still need to figure out current, so we're going to utilize Ohm's law to do this. Once we figure out current, then we can also figure out what our voltage drops are going to be. So let's go off of what we're already given. We're already given voltage. We're given the resistance of all 3 resistors. So for a series circuit, all we need to do is add the amount of resistance in each resistor, and that's going to give us our total resistance. It's pretty simple math. So we're going to add 300 ohms to 600 ohms, which is 900 ohms, and then add another 300 ohms here. That's 1200 ohms total resistance in this series circuit. It's pretty simple. I'm going to write that down for us. So what we can do from there, now that we've got 2 of the parts of Ohm's law, we know we can figure out total current. And that's simply going to be by dividing energy by resistance, or voltage by resistance. So that is going to be 120 divided by 1200. And that's going to give us our total current of 0.1 amps. You could also call that 100 milliamps if you wanted to. To do that, we would just move the decimal 3 places. But for this purpose, we're going to call it 0.1 amps. So now we've got all the information we need to calculate our voltage drops through this series circuit. Okay, so let's do this first. As I had mentioned before, there are 3 basic rules for a series circuit, of which I've posted already in this video. One of those rules is that the current is always the same in a series circuit. So we just calculated our total current. What we know then is that that current is going to be the same at all of these resistors. So I'm going to go ahead and fill that in. So if you look at that, now what does that give us? That again gives us two pieces to Ohm's law, so we can figure out the third. We've added up the resistance to give us our total resistance. We divided that into the voltage, which gave us our total current, which is the same anywhere on a series circuit. Once we plug those numbers in, now we can calculate the voltage drops at each of the resistors, and we'll have all the data we need for this series circuit. So some simple math tells me that if we multiply I times R, that's going to give us E. So here we're going to multiply I times R, so 300 times 0.10 amps, that's going to be 30 volts. That is our drop at that resistor. We can do the same math here, 0.10 times 600, that's going to give us a 60 volt drop at that resistor. And again, we're going to have the same math here that we had on resistor 1 because it's the same numbers. So it's going to be 0.1 times 300. It's going to give us a 30 volt drop across that resistor. Now, as I said in the beginning, the total of the voltage drops in the series circuit is going to add up to the input voltage, always, every time. So if we look at the numbers we just figured out, we've got 30 volts plus 60 volts, that's 90 volts, plus another 30 volt drop, that's 120 volts. Those voltage drops add right back up to our input voltage. So you can see here that I've gone ahead and erased our data that we just calculated. And what we're going to do now on our trainer is get some actual readings and do some math and take some measurements and make sure that everything figures out. So let's get to measuring on the trainer. Okay, so I'm sure you've noticed the scenery has changed. We had technical difficulty at our other location, and we had to switch things up a little bit, but let's keep going here. We're going to take some real-world readings off of our trainer, and then we'll do some math on the whiteboard and see how this all plays out. Okay, so let's check for resistance on resistor number 1. And of course we do that with no power applied to the circuit. So we're just going to hook up our digital multimeter here. And while I've got it set at 300 ohms, the actual resistance is 298 ohms. And I'm going to write that down, and that's what we're going to use for our calculation. Okay, and now we're going to check resistor number 2, which we had set for 600 ohms. And we're showing here that that's reading actually 640 ohms. I'm going to go ahead and write that down, and that's what we're going to use for that resistor. And finally, we're going to check resistor number 3, which is set for 300 ohms, and the actual reading is 297 ohms. So we're going to use that on the whiteboard for our calculations. Okay, and now we'll check the power supply to see what the utility is supplying us today. We're going to check it from line to neutral. Should be about 120 volts. And today they're giving us 118, almost 119 volts. We'll call it 119 for our purposes. Okay, so now that we have our measurements, I've gone ahead and written them in on the whiteboard for resistor 1, resistor 2, resistor 3, and of course our total voltage. And what we'll do next is take the resistance and add them up. That's how we calculate total resistance in a series circuit, is by simply adding the total number from each resistor. In this case, if we add these 3, that gives us 1,235 ohms of total resistance. Now, what we can do now, because we've got 2 pieces of the Ohm's law puzzle, is we can divide our total energy by our total resistance, and that's going to give us our total current of this circuit. So we simply divide 119 by 1,235, and that gives us a current of 0.096 amps. Now, what we know, according to the laws of a series circuit, is the amperage is the same throughout that whole circuit. So we know that the amperage is going to be the same at resistor 1 as it is at resistor 2 and it is at resistor 3. So I'm going to go ahead and write those in there. Okay, and what that does by putting those numbers in there, we've now got the two pieces of the puzzle for Ohm's law to figure out our voltage drop on each of the resistors. And we do that by multiplying the current times the resistance. So for resistor number 1, our current of 0.096 multiplied by 298 ohms is going to give us a voltage drop of 28.6 volts. Okay? On resistor 2, we're going to multiply the current of 0.096 by the resistance of 640, and that's going to give us a voltage drop of 61.4 volts. Now, resistor number 3 we know is going to be very similar to resistor number 1. They're almost the same resistance. And we certainly know that they are the same current because the current's always the same in a series circuit. So our voltage drop for resistor number 3 is going to be 28.5 volts. And if we take and add up the voltage drop of all three, across all three resistors, we're going to come up with a voltage. The number is actually going to be 118.5 volts. It's very close to our input voltage of 119. So like I said before, the sum of the voltage drops on all the resistors is always going to add back up to the input voltage. So now let's wire up this circuit and we'll check our math with the multimeter and make sure that everything works out according to the way we think it's going to. Okay, I've gone ahead and wired up the circuit like we have it on the whiteboard, and we've already measured the resistors, so we know what those numbers are, and those were recorded on the whiteboard. And then we've calculated our current and our voltage drops. So let's see if our math works out. So we calculated the voltage drop on resistor 1 to be about 28.6 volts. And so we'll connect this in parallel. And I'm reading about 28.4 volts. So that's close. I would say our math is good. Let's check resistor number 2. Now that was 640 ohms. With 0.096 amps, we calculated that to be 61.4 volts. And our voltage drop there is about 61 volts. So that's good too. Our math is good. Let's check resistor number 3. And again, on that one, we calculated about 28.5 volts. And our voltage drop there is right under 28.5 volts. So far, our math is correct. The voltage drops that we calculated across each resistor, according to the input voltage and the resistance of each resistor, so far we're on track. So next we're going to try reading the current and make sure that math was correct also. Okay, so what we calculated total current to be is 0.096 amps. And as I've been repeating throughout the video, that current is going to be the same wherever we read in the circuit. So let's start with the wire coming out of the power supply before it goes into resistor number 1. We'll let this guy settle down a little bit. That's showing us 0.093 amps. That's really, really close to what we calculated. So I'd say our math is good. Now we're going to check the wire between resistors 1 and 2. And it should be the same because we know that the current is always the same in a series circuit. There is current of 0.093, so that's close. Let's check between resistors 2 and 3. And that's going to settle down to 0.093 amps. And finally, we'll check the last wire that goes back to the power supply, and we'll see what that settles on. And it looks like we're going to settle right back at 0.093, like we know to be true, that the current is always the same no matter where you measure it in a series circuit. All right, so let's recap what we've done here today. In our real world readings on the trainer, on the power supply, we've got 119 volts. And our actual readings of the resistors are here, 298 ohms, 640 ohms, 297 ohms. And we know we just add those up because it's a series circuit. So we add up those resistances to give us our total resistance. And then once we got those two numbers, we know it's a simple math equation to divide 119 by the resistance, which gives us our total current for our series circuit. And as I've said before, we know that the current is the same in a series circuit no matter where you measure it. So we get to plug that number in at each of these resistors. Once we did that, we were able to multiply the current by the resistance, and that would give us the voltage drop at each of the resistors. And again, reminding you that the individual voltage drops at each of the resistors, we know will add back up to the total input voltage. All right, once again, I want to thank you for watching this episode of What the Heck is Steve Talking About? As always, my email address will be down below. If you have any questions about anything you see on this video, or if you need help figuring something out, or if you need to get in touch with an instructor for some help, please send me an email and I will get you the information that you need. Thanks for watching.